My name is Nick Grady, and I'm the plant manager here in Groveport, Ohio, where we make water treatment equipment. And today I'm going to be taking you on a tour of our factory, which includes a molding facility with 17 injection molding machines and 250 molds. So let's go take a tour. So here we have our 770-ton machine. So that means it has 770 tons of clamp force. And it takes polypropylene material from our silos outside. It's fed into the machine, here into the hopper, where it goes into the barrel. Inside the barrel is the screw, an auger that forces plastic with pressure up to the front of the barrel. There, it's melted to about 400 or so degrees, and it's pressed into that injection mold. It will then come out as a molded part after it's cooled in that negative void. And that's what's unique about our product, is that we have injection molded tanks, whereas so many others use fiberglass tanks. That's a unique aspect of the Hague product. So here we have a tank top. Now what's interesting about this is that this tank top, any feature that's on this must be in the negative in the mold. So if you want a feature here, or if you'd like threads here, that has to be in the negative in the mold. And once it's filled with plastic, how do you get it out? Well, what has to happen is the machine has to have a lot of programming and electronics to be able to remove the inserts so that we can get the part out. Well, what about this threaded part? How do you get a threaded part out? We literally have to have cores that unscrew and remove before the part can come out. And that's how these tools become extremely complicated and technologically advanced. But that's not all. Once we've got this part molded, it then has to enter into our cooling chamber, because this is an extremely thick injection molded part, about 3 to 400 thousandths. So what that means is that this is still molten inside when it comes off the machine. It has to cool for several seconds before we can take it on to the next process. So from there, we do some ultrasonic welding. We put it in a reamer, because what's interesting about this part is that it has to have a perfect seal, or else hard water will leak, which would render the water softener pointless. So we have to have a perfect diameter, only 2/1000ths of an inch tolerance. The only way to accomplish that in an injection molded part is to actually mold the bore too small and then ream it out to the perfect size. So we actually over mold this and then ream out the center of it. From there, we're going to put another unique Hague aspect into it, which is our screens. This keeps resin from getting out into your plumbing and causing issues in the house. So we'll take this top, we'll put a screen in it, and we'll place it in our laser welder. And with a laser, we will weld this screen into your water softener. What's really fascinating about this is that this screen, after it's laser welded in place, has a strength of over 2,000 PSI. So it can withstand serious amounts of force that it may encounter when it's in operation in the home. Now that those tops and bottoms have been molded, we need to bond them together. We have two ways of doing that. One is with our EmaBond tape. So this is tape that has metal flex in it. We place it on the bottom, connect the top, and put them into our EmaBond welder. So this will place the unit in a magnetic field, and it will cause the metal to heat up and bond the two pieces together. The other way we weld tanks is what's called vibration welding. So we'll take that top and bottom, place them into this machine here, which will actually vibrate the two halves together until there's enough friction, creates enough heat that the two are welded together. What you end up with is a tank that can withstand hundreds of PSI. So here we have our small parts department, where we collect several of the parts that we manufacture injection mold here in-house and combine them into the brains of the water softener. We take parts that we have molded, turn it into a valve. We place a motor on it, gears, hydroslide, brine valve, a number of other things that control the water softener. And here we have our fill station. So we're gonna take those tanks that we just completed, and we're gonna fill them with resin, which of course actually cleans the water. So the resin will come from our hopper up above, and we will fill it into the tank using a vacuum. And it'll then have a few extra added bonuses of maybe some garnet or another type of media. And from there, it'll go on to our assembly station. And here we have our assembly station. So we're going to take that brain that we saw earlier, we're going to connect it to the body of this unit. So now that we've got a filled resin tank, we're able to assemble all of these parts together, the bypass, the drive end cap, with the resin tank to get a completed unit. Now that we've assembled the unit, we want to test it. So we take this completed unit, we roll it over here to our tester, and we'll connect it to our tester head. This is a state-of-the-art tester that's unique to Hague testing. There's no other facility that does this. It's going to check for flow, for motor function, for leaks, and a number of other concerns to make sure that our product quality is excellent. Now that we've got a nearly complete unit, we're gonna take this, place it in the cabinet, put a safety shutoff in place, and then we're gonna go on down to boxing. Place it in a box, but we're not quite done yet. We need to do one more quality test. We're gonna plug in the controller just to make sure it operates as intended. We're gonna send it through the tape machine, onto the pallet, and off to the warehouse. Thanks for coming on the tour today. I hope you see the advantages of being a Hague customer. We look forward to doing business with you.